rotor and the PIXL are two instruments that enable us to move and manipulate very large numbers of yeast colonies across agar plates. This is important for us because it allows us to operate on a scale that would be otherwise impossible. Recombia, projects basically begin with a rational engineering approach where we take information from the literature and from our own experience and design genetic changes to strains that allow an improvement. But what we've learned is that biology is complicated and often there are unpredicted consequences of making such changes. So it's important to complement those rational approaches with systematic, unbiased screening of large libraries. And that's what the PIXL and the rotor allow us to do. So at Recombia, we take our gene editing technologies and use that in combination with the PIXL and the rotor to generate large arrayed collections of yeast strains that we then subject to high throughput screening testing, either here at Recombia or through our partners in France at the Biofoundry. And what we found consistently with doing these screens is that the screens identify changes that we didn't anticipate beforehand. So it just underscores the importance of applying a systematic approach to discovery. In addition to that, I'll say having access to the equipment lets us think about experiments in a different way and doing things at a different scale. And through that, we've actually developed innovative methods just by being exposed to those types of instruments that we would not have developed otherwise. The previous colony picker that we had been using had some issues with dependability and also sterility. So we started looking at the PIXL as an alternate solution. We really like the small footprint of the instrument. Oftentimes in labs you don't have a ton of space to keep equipment. We also were intrigued by the innovative design with the plastic filament feeding through and picking that way. And we had a great experience with the rotor in terms of technical support from Singer Instruments. It's always been great. So we took a shot at the PIXL and it's worked out really well for us. The main thing for us with the colony picking was reproducibility and also dependability. And so when we tested the PIXL, it seemed to check those boxes off very well, and we've been very happy with it ever since. The main motivation behind that upgrade was to automate some of our cloning and strain engineering workflows. And so the retractable door on the PIXL Dark allows it to interact with a robotic arm that can add or remove or replace plates on the PIXL deck. So we're still working through some of those workflows now, but some of the things that we're actually using it for currently are to consolidate libraries. So we have several very large complex libraries that consist of many clones, but we can use next generation sequencing to identify non-redundant sequence validated clones within that set, and then use the PIXL to cherry pick out those clones and consolidate the library into a smaller set of clones. And that allows us to reduce the number of consumables and the time it takes to test those clones. So in our design build test cycle, the test remains sort of the bottleneck of the whole process. So being able to reduce the number of clones down to a smaller, more manageable set is very important to us. I've not been able to utilize actually, that's not true. I have, but I can't answer that question. I'll neither confirm nor deny that we've used the beer bottle opener